Hi, I'm Tom Trams with the FujiNet project. I'm making a video here showing how you can set up development tools using a Linux virtual machine, using a piece of software like KVM or VirtualBox, so that you can have a completely self-contained and well-functioning development environment for creating ColecoVision and ColecoAtom games or applications. This will be very straight to the point. There really won't be any FujiNet stuff in this video here. The whole point of this video is very straightforward. We're going to take an installed copy of Ubuntu Linux that's in a VM and install the Z88DK compiler, the ColEm emulator, and we're going to integrate it into the desktop environment so we can take and do some test compiles to make sure that the compiler works, that it can create functioning ROMs and data packs, and take you on to the next phase where you can actually start creating software using the integrated environment that we're putting together. What we have here is basically a copy of the latest copy of Ubuntu 23.04 at this point that is installed in KVM. Again, as I've mentioned before, you can use VMware, you can use VirtualBox, you can use Hyper-V if you want. It's all up to you, and you can do whatever you wish. You can even install this as WSL in your Windows environment if you wish. But I'm doing it this way to basically show consistently, to create a consistent environment here. So with that, let's get started. We have here a nicely freshly installed environment that's been updated. Everything's good. I've went ahead and went through and did all the display settings so that it fit the screen on this quite nicely. I went through and turned off the turned off all the blanking so it doesn't blank on us, turned off the screensaver, and etc., etc. Made everything all nice and neat here. I'm going to pull my OBS window out of the way so I can see my little script here so we can have something to work out. So the first thing we absolutely need to do, we need to open up a Firefox window here, and we're going to go to GitHub real quick. And we're going to go to the Z88DK page here. Well, we can go here, Z88DK, in the home page here, and we can go to documentation. And you can see it takes us to the wiki page here. And one of the bits and pieces on the documentation page here is installation. Clicking on installation will give you pretty much everything you need. It tells you in detail all the bits and pieces that you need to take and build a copy of Z88DK with sections for each operating system that you want to use, be it Linux, be it Mac OS, be it Windows. Doesn't matter. So in our case, we're going to be following the Linux and Unix instructions here. We're going to take this window here, we're going to pop it to the side, bam, snap it to the side of the window there, just pull it to the edge of the screen and it will snap. It's quite nice in that way. And then we're going to take and open up a terminal. We can do that right here. It'll toss us into the desktop folder here. Now, for ease of use here, I'm actually going to take this icon here, I'm going to right click on it, and I'm going to pin it to the dashboard so it's here. Works like the Mac OS dock in this case. Bam, there we go. We now have a browser on the right. We have our terminal window on the left. We're going to go ahead. I'm going to CD, so go all the way back into the home folder. And in point of fact, if we actually took and started terminal, if we had done it like this and started it this way, or started it from here, it would have dropped us straight here into the terminal, into the home directory to begin with. Such is life, but now you know. So, first thing we need to do is we need to get a copy of Git installed, and we'll use the apt utility for this. Apt install Git. We enter the password that we did when we did the install here. Now, you'll notice I didn't go through the install process of Ubuntu, and that's because there are plenty of videos and tutorials on how to do this inside of a virtual machine. It's beyond the scope of this video here. Didn't go into that. We don't need it. So now that we've installed Git, we can take and grab the latest copy of source code and put it in the Z88DK folder here in our home directory. And you can see right here, it's pulling the latest copy of the source code down from GitHub. Wait a few moments for this to complete. And because we specified recursive, it also checked out any sub-projects that it needed in order to build. That's the first step. The next thing that we have to do is we need to install additional packages that the compiler will need in order for it to be built. We'll go ahead and do that. You can see it's a whole bunch of packages that just got pulled in here. You can see things like the C compiler. You can see various libraries like Boost flying by, various libraries like ICU for Unicode, all sorts of stuff like that. But basically, Z88DK is the compiler that we're going to be using to build our software. And it's a wonderful suite of applications that comprise two compilers, two standard libraries, one that they call the classic and one that they call the new library, a set of example programs with a test suite and everything else, everything that you need to develop ColecoVision or Coleco Atom applications using either C or assembler, all in one place. It's very convenient. And in fact, if you want to, you can take the opportunity here to go back through the documentation here and look around the Z88DK site to see what's possible and what all is available here. There's all sorts of pinned documentation to show all the different features of the system, such as graphics routines, you name it. It's all here ready to be used. We'll come back to where we were now that this is done. We've installed a bunch of system packages, but we also now need to install a few Perl packages. Luckily, we have a command here to do that for us. We copy that in, we paste it in, and we wait a few moments here. Now, it's going to show a crash here. This is nothing to worry about. It's because it's replacing a system package here. That's fine. Don't send anything. Just let it do its thing. Nothing is hurt. Nothing is harmed. And while that will scoot down the instructions for the next phase when we're ready. And for this next phase, what we're actually going to do, we're going to go into the Z88DK folder here, and we're going to use this shell script right here to take and build the entire compiler suite. But we need to set some environment variables here to make the job a bit easier for us. We want to build the additional compiler, the SDCC, on top of the small c compiler that normally comes with Z88DK in the first place. I will make another video basically comparing the differences between SDCC and SCCZ80, but suffice it to say, you really do want both of them there, because they do have their each have their own unique advantages. And as part of building SDCC, we want to be able to take and fetch it from HTTP, which will be a lot faster. Finally, we give the build script executable permissions, and then we run it in that current directory. So we can do all of these instructions all at the same time. We can paste them all in one big block, and it will do the right thing after we press the return key. And we can see right here that it is actually taking and building out the compiler and all the bits and pieces. This process right here will take approximately anywhere from 15 to 30 minutes. So go grab a cup of coffee, take care of what you need to take care of. I'm going to pause the video here while this completes. And with that, we finished the compile here. In my case, it took about 25 minutes from start to finish. And if you watch the compile, you'll see all sorts of interesting stuff fly by for different systems. Yes, there are libraries for the Sega Master System. Yes, there are libraries for all these different systems that you can take and build with this compiler. So you can target a whole bunch of other machines with similar C code. Anyway, so with that, let's take and continue. The next thing we need to, let me look at my little script here to make sure. The next thing we really want to do is take and grab the Coleco ColEm emulator, which is written by Marat Faizullin. This emulator has existed since time immemorial. I mean, late 90s. I think the first version came out in 98. But he's been steadily just maintaining it over the years, adding features and keeping it up to date. And we have a binary here, a binary distribution for Linux directly, so we don't have to compile it. That's great. Let's take and grab it. Let's take a look at it here. Go to the folder. Let's take a look. We can extract it. We'll extract it right here. It gave it a folder. Let's take and cut that folder, put it back in our home folder here, so we can have access to it. And I'm going to rename it to just be ColEm. So there it is, and we can test to see if it works. If we take and click on ColEm, bam, we can see the ColecoVision works just fine here. We can resize the screen, do whatever here. Okay, great. So this works. We can close that. You'll notice that ColEm comes with the necessary ROMs for ColecoVision support, as well as the necessary ROMs for the Coleco Atom, the EOS, and the SmartWriter ROMs, already packaged and ready for you to go. There's also a user manual here that you can kind of thumb through, so you can see the various keys and things, so you can look to see how to operate the emulator. So all of that is right there, ready for you to use. Cool. So that's there. We want to take and integrate this in a bit further so that when we click on ROM or DDP files, it will take and launch ColEm for us automatically. And for that, we need to create a couple of things. An application file to take and map it into the applications menu. And we need to create some MIME type files so that it knows that it can open ROM and DDP files with ColEm here. So let's start with that. The first thing we need to do is go grab an icon. Well, that's easy enough. Let's just go grab one. ColEm ColecoVision emulator icon. Well, gosh, that looks nice. Okay, let's go images here. Let's just take a look at it. Perfect. Okay, we take that and we save image as. And we go ahead and, that's WebP. Let me take and find a nice little ping of that. I don't know, maybe that one. That good? That's got transparency. There should be at least, I think that's let me take a look. Copy image. We'll take and copy image here, and we will do a couple of little tricks here. Now you'll see this is our home folder, but there are some hidden folders inside of here that we currently do not see, and we need to go into them to add a few things, to add our applications file, to add our MIME files. Show hidden files. We can see there's a folder here called .local. Go into .local, go into share, and then we have applications here, and we actually need to create a folder called icons to put our icon here. So new folder, icons. Drop it into here, and I took and copied the image. I'll do that again. We can take copy image, paste, and there's our pasted image, ping, ready to go. Bam, there's our icon. We'll just rename that to colem.ping. There's our icon, ready to go. And we now need to open up our text editor that we're going to use for a few things in this particular tutorial. We go down here to the applications icon here, and we see all our applications that we currently have installed here. And the one that we're interested in is text editor. But I want to take and we're going to be using this a lot. You may be using this to edit code. So it's a good idea to take and add this to our favorites. So it shows up here on the left-hand side. Boom, you can see that that's gone. It is now shown up over here. And now if we open it up, we can see our text editor come up. The first thing we need to do is we need to make our application file. Now there are web pages showing how to make desktop files here, but I'm going to take one that I prepared over here and I'm going to cut and paste it in. This is our ColEm desktop file. Boop. And this has everything that GNOME needs in order to take and launch the application, including where the executable is. It's in the folder that we set aside for it here. And there it is right there. The name that we want it to appear as, the icon that we want to use, which points to this guy right here, and the types of files that we know we want to open. We are going to create 2 MIME type files for these 2 types here so that it knows that it can open them. But first we need to create this. Let's go ahead and press save. And we're going to go into, I'll take and make this a little bit bigger so we can see everything. And we're going to go into local, we're going to go into share, we're going to go into applications, and we're going to create our little ColEm file. ColEm Desktop. Bam. So now we've done that. And in point of fact, if we actually take a look now, we will now see that ColEm has now shown up in our applications menu. We can launch it that way if we wish. Boom. Okay, but let's make it more useful. Now we're going to take and make the 2 MIME files. So for that, we're going to go ahead and make a new window, either that or make a new tab. We'll go ahead and close this one because we're done there, sure. And we will bring in the first one. This is an XML file. And this basically tells the system here that for this MIME type that we specified in the applications file, applications XROM, it's a ColecoVision ROM, and we're going to match all the files that end with .rom here. And we're going to take and set this up here. This needs a bit more work. I'm not going to talk about it here, but if you can get this to work, great. Let me know. I'll update the video. So that's our MIME type file, so the system knows that we can deal with that. Let's save that. Save as. Let's go back. We can see right here, boom. We need to create a new folder. Create a new folder. We'll call it MIME. And we'll create a new packages. Create. And we'll call this application xrom.xml. That's it. Boom. Now, if we take a look, we'll see that the file's been created in packages. We have this file right here. Okay, great. Let's make a new file here. We'll go ahead and close this one. We're done with it. And the same thing over here. This is the one for the DDP. It's much the same way. It's just everything's been replaced with DDP, and we've given it a descriptive name of Coleco Atom Data Pack. So we'll go ahead, save this. Application xddp.xml. Save. There we go. There are our 2 MIME type files here. Now, with this, we actually are going to have to tell the system that these 2 files are here and that they need to be populated into the system so it knows it can use them. A good thing, we can open up a terminal window. We'll go ahead and close this one because we're done with this one. We'll open up a terminal window. Update MIME database. Dot. So, oops, sorry, we need to be one level down. So there we go. Boom, it shows us right here. So what we really need to do is this. Apologies. Local, share, MIME. Boom. So now it's updated the path here. You can see that one corresponds to this one right here. Boom, okay. So now we've updated the MIME database. We need to update the application database so that it knows that it can deal with it. So local share applications, sure, okay, great. And with that, we should now have everything reasonably integrated. We can do the last part of this tutorial, which is to create a test program to make sure that our stuff is running, build it, and then run it. So for that, we'll go into our file window here, and we're done with the hidden portion here. We can turn that off, clean up our directory listing quite considerably, and we can make a new folder. We'll call it Workspace. And inside that workspace, we'll create our first little semi-project here called Hello. And inside here, we'll take and create our first little piece of software here using our text editor. We're done with this, so just close off that tab. And for this is the simplest possible program that's in C. It's what we always do when we're writing something in C. We make a program that simply types hello world. We start with an include statement, which includes the printf statement that we're going to need, and we create a function. It doesn't return anything, so it's void, and the function's called main. Every C program has a main function. It has no parameters because we're not processing anything, so every function is surrounded by a set of curly braces here. Printf, use the function, hello world, and we'll do this all in caps. Hello world, dot. There we go. So we save that. We go ahead, come back, and what I'm going to do here, I'm going to take this folder right here, select it, and then add to bookmarks, so that that folder is always here and always ready to be used. And so I can go straight to it. Hello.c. Boom. So we've saved that. And if we take a look, we can see our hello.c source file right here. And at any time, if I take and click on it here, it will open that up in the text editor ready for me to edit. Okay, cool. Now let's actually take and build this. I'm not going to go into the process of makefiles or anything here because right now we're just testing the compiler and everything is in this one source file anyway. So we're just going to call the compiler directly. To do that, we'll use a little shortcut here, right mouse button, open in terminal. Bring us right to that folder right there, ready to go. And at that particular point, I can, looks like I skipped over a particular piece of something I needed to do. I apologize. Let's go ahead and fix this real quick. Darn. I let myself run, but no problem. This is easy enough to fix. Show hidden files again. One of the hidden files is the bashrc program, which is run each time that a new terminal window is opened. Let's open it up, take a look at it. And there is, at the bottom, these are all commands that are run each time a terminal window opens. It sets all sorts of nice little things like command aliases and the like, and you can alter these things to your benefit, however you want. This is the copy that's in this home directory. We need to add a couple of lines here. And these are actually in the Z88DK installation guide here. This will allow the ZCC command that's in Z88DK to be visible. It puts Z88DK in the path. It sets the default configuration file directory so that Z88DK can find all the system targets and make sure that that the Perl search path and everything is properly set as well. Everything good, everything working great. Beautiful. That's all we need to do. We'll take and save that. Boink. Apologies for skipping over it. I guess it just excited was trying to show you guys this stuff that I skipped over it. No big deal. So, back to that. Let's go ahead and unhide this again. So now I'll do this again so that we're back in the same space here. Workspace. Hello. Open terminal. Now, if we run the ZCC compiler now, we'll see that it runs. It gives it a list of options because we didn't provide anything, and it gives you kind of a quick little help showing you all the different options that are available. And you'll see that as part of how it works here, we need to provide a target, which begins with plus. We need to provide any options that need to be set, such as the output files. And we also need to provide the list of files that we want to take and compile. Okay, so for this, what we're going to do to compile our source, run ZCC, we need to provide the Coleco target, and we're going to use an option here called Create App. Create App is kind of special because it runs app make to create something that can quickly be run to be copied to a real machine or run in an emulator. It quickly packages up different things in a runnable format. And the format that it uses is dependent upon the target that you select. For Coleco, this means packaging it up as a cartridge ROM. For Atom, this means packaging it up as a bootable digital data pack file. So with that, we continue and specify an output file. We'll call it hello.rom. And it's going to be built from hello.c. And you see there were no errors because it immediately came back and built our things. There's a couple of artifacts that it built here that are binary files. These are intermediate files and they can be deleted. And what we really want here is our ROM file. Now, because we have actually taken and built this, well, that's interesting. Let me take and pause and see what actually happened here. Interesting. Let me build that again. Huh. Okay. Give me just a moment, fellas. Oh gosh, I have egg on my face. This is the second mistake I've made in this video. I forgot to add a very important output. Create app. The one I mentioned before, the one that creates a file that you can run directly. Boom. So now we've done that. It creates the file. And in fact, if we look at the file itself, you'll see it says ColecoVision ROM is 32 kilobytes in length. Okay. Now if we run it, we'll see that it's running. But one interesting thing that's happening here, you may not be seeing, it's just barely blinking here. You're seeing hello world for a split second, and it's just rotating over and over and over again. And that's because the program is constantly restarting. Whenever the C programs are executed, each instruction one at a time from top to bottom. And once main is finished, the program exits. Well, there's nothing really to exit to, so it just restarts the program. Well, so we need to add one thing here to take and make sure it sits and spins. And while we have a while statement here with a condition of 1, which is 1 is always equal to 1, so it's always true. So it just sits here spinning. We'll go ahead, save that. Boop. And we will rebuild. Same thing again. Now, we'll see our hello world here. Boom, we've made our first ColecoVision application here. Now let's do the same thing for the Coleco Atom data pack. Close this off for a moment. All we really have to do, we don't have to change the program code at all. The thing we have to do is set a subtarget. Subtype equals Atom. And we're going to change hello ROM to hello DDP. Now, it created a few other intermediate files here, including a bootstrap loader here for the front of the file. But you'll see now that we have a DDP. If we look at the properties, we'll see it's a Coleco Atom data pack that is 256K in length, basically. But if we take and run it, we'll see that it executes as Coleco Atom here. And to prove the point, we're actually going to take and do one more thing here to prove the point, to show that it's actually running the differences here. We're going to change this to use lowercase. and the lowercase between the ColecoVision and the Coleco Atom are two totally different things. Two different fonts. We'll save it, and we'll rebuild here. Boink. And we'll go back and create that one too. We'll create both of these. Now, if I take and open the Hello ROM, you'll see that this uses the lowercase in the ColecoVision here versus the lowercase in the Atom ROM. And you can see, yes, we can run multiple copies of ColEm here to run it side by side. So there we go. We've taken our first step into setting up a complete development environment inside Linux here to develop ColecoVision and Coleco Atom titles using C and using the Z88DK compiler, which can do either C or assembler here. I hope you guys have found this informative, and I will be making more of these as time permits here, exploring all the various aspects of C, giving basic C tutorials, showing how to do various different things, because I want people to have a good record of how to take and develop applications easily for this platform. So with that, I'm going to end the video here. As always, guys, have fun.